Adam, dude, do you remember anything from the dilution you did in chem? I forgot everything we learned.
OMG, I had the same problem. You had to check out this video. It's a total lifesaver. It's on this thing called Paul Academy. I have to say, bro, it's really great.
Thank you so much.
Is it just me or is this lemonade way too sweet?
Yeah, mine's really sweet too. Maybe it has a high sugar to water ratio.
You mean it's too concentrated? I mean, there has to be something we can do to make it less sweet. I can't drink it like this.
Didn't we learn something about dilution in chem class last week? Maybe we could do that to our lemonade.
Yeah, that's a really good idea. Let's go inside and figure this out.
Alright, so what do we actually know about lemonade?
Well, we know that lemonade is a solution, which is a homogeneous or uniform mixture of a liquid with another substance. I guess we could also say that the solvent, which is the liquid that dissolves another substance to form a solution, would be water. The solute, which is the substance that's dissolved in the solvent, would be both the lemon and the sugar. Since our lemonade's too sweet, we would need to add more lemon water to dilute this.
Also, I remember from chemistry class that the equation for dilution is C1 times V1 is equal to C2 times V2. Also, I read this BuzzFeed article that said that the molarity for the perfect lemonade is 0.6 molar. So that would be the concentration of the substance we're trying to make.
So when we're making the stock, or the original solution, I know that we added 1.5 cups of sugar, which is about 300 grams. And then the total volume of our lemonade was about 1,375 milliliters.
So we already know C2, and from what Joy said, we know V1. Now, all we need is to solve for C1, and then we can solve for V2, which is how much lemon water is in the final solution.
I think I remember some kind of equation for concentration. What was it again? Concentration equals volumes over moles?
No, Joy, it was C equals N over V.
Oh yeah.
So we already know V, 1,375 milliliters. And we need to find N, and we can do so by using the equation N equals mass over molar mass. Miss Pauls drilled that equation into my brain after the quantitative chemistry unit. I'll never forget that now. We know that the mass is 300 grams, and the molar mass is the addition of all the atomic masses of all elements within the chemical formula of the solute, sugar. Since the chemical formula is C12H22O11, the molar mass must be 342.3 grams per mole.
So this means that we can fill in the blanks of the moles is equal to mass over molar mass formula and find the value of moles to be equal to 0.876 moles. And now if we divide this by the original volume, which is 1.375 liters, we'll get the original concentration to be 0.637, which is already all written on the board for you.
Oh, so if we sub that value into our equation, C1 times V1 equals C2 times V2, we can see that our final volume of our lemonade should be 1,460 milliliters. So, subtracting our original amount of lemonade from that means we should add 85 milliliters of water to dilute our lemonade to perfection.
I can't believe how easy it was to apply dilution problems that we learned in chemistry class to the real world.
I know, right? All we had to do was use the equation C1 times V1 is equal to C2 times V2. Finding the volume or the concentration that was unknown was easy using the formula concentration is equal to moles over volume. And finding the moles was even simpler with the equation moles is equal to mass over molar mass. Chemistry is awesome!
Chemistry is awesome, but just a few things we should probably take note before we do our next set of dilution problems. So the units for this equation don't always have to be the same, that is liters per volume. A volume could also be expressed in milliliters, and concentration could be expressed as percentages. But these units should not be changed within the calculation, so it should be constant throughout. So if V1 is expressed as milliliters, then so should V2.
That makes sense.
After all that hard work we put into making the perfect jug of lemonade, I think we should enjoy some.
It's perfect!
Adam, I'm stuck again. This time I have no idea about this net ionic equation stuff. Do you have another one of those Paul Academy videos?
I got you, bro.
Okay, so the recipe calls for 2 teaspoons of baking soda and 2 tablespoons of vinegar.
Wait. Don't you mean sodium bicarbonate and acetic acid?
Wow, Nora, you're so smart. Miss Paul would be so proud.
I know.
Oh my god, there's a reaction.
We should see what kind of reaction occurs between these 2 ingredients.
Yeah, that's a really good idea. So these 2 would be our reagents, right? Like the starting products and materials of the chemical reaction. So the substances that are formed would be our products. Okay, so the formula for sodium bicarbonate is NaHCO3, and for acetic acid, it's CH3COOH.
Hey, isn't it an acid-base reaction then? I'm pretty sure it's a double displacement reaction, right? So one of the products is sodium acetate and the other must be carbonic acid?
Yeah, that's right. But don't forget that carbonic acid readily decomposes into water and carbon dioxide. So that would be written within the equation instead.
Yeah, exactly. So it's a double displacement reaction followed by a decomposition of carbonic acid. But wait, guys, we forgot the states. Acetic acid has to be aqueous, as in a solution that uses water to dissolve or break down a substance, because it's an acid. Baking soda is aqueous because everything that combines with sodium is soluble according to the solubility table. Water is liquid and carbon dioxide is a gas, and sodium acetate is aqueous too, right?
Yeah, so all we need to do now is balance the equation. Here, let me handle it.
2 hours later.
Joy, it's already balanced.
So now let's try to find the net ionic equation. That way we'll know exactly what's happening in the reaction and what doesn't actually participate.
Okay, so what do we do first again? Do we split up the compounds or something?
Yeah, exactly. We dissociate the ions. But it's important to note that only the aqueous compounds can actually dissociate because the solids, liquids, and gases have too much of a strong attraction holding them together, so they can't.
Exactly. So as you can see, this is the total ionic equation. As you can see, the aqueous compounds dissociate while the liquid and gas don't.
So there's 2 spectator ions in this equation. Spectator ions are ions that are the same in the beginning and in the end, so they don't actually participate in the reaction.
Wait, isn't sodium plus the only spectator ion?
No, Nora, see look, these 2 are both acetate. They're the same compound, just different formulas. So these are also spectator ions.
Oh. Yeah, exactly. So then we can cancel these out, and we're left with our net ionic equation.
Hey guys, that was actually really easy. All we did was write the balanced chemical equation
With states.
Yeah, and then we dissociated all the aqueous compounds, but not any other state, because those were non-dissociable. And all of this made up the total ionic equation, or the TIE.
And after that, we canceled out all the spectator ions because they don't actually participate in the reaction. That left us with the net ionic equation.
So we know exactly what's happening in the reaction of baking soda and vinegar. Can we keep making our cake?
Yeah.